Hey guys, welcome back to AlgoYogi. We are now doing stack series, and our second problem in the list is basketball game. So let's go to the problem on LeetCode. You are keeping the scores for a basketball game with strange rules. Yes, of course they have to be strange rules because simple regular rules are simple. Okay. At the beginning of the game, you start with an empty record. You are given a list of operations where operations I is the ith operation you must apply to the record. Okay, and initially record basically starts with empty record, nothing. So an integer in our record is basically a score of x. That means we have to add that much to a score. Plus sign means a new score that is the sum of the previous two scores. All right, and if you see a D, that means record a new score that is the double of previous record or previous score. And then C, that means invalidate the previous score, removing it from the record. We are doing a stack series, so by now you know, like, that's the data structure we will be first relying on to solve this problem. Now we need to return the sum of all the scores on the record after applying all the operations. A test case are generated such that answer and all intermediate calculation fit in this blah blah, and all the operations are valid, which means that when you're doing this plus operation, that means there should be two scores below on this stack already, so that we can basically pop those two out and perform the operation and then sum them up and then put them onto basically the score. Okay, sum of the previous score. Okay, now I think this is really clear. Now let's understand on iPad how we are actually going to do it. I think the key to this problem is basically going through these operations and doing exactly what has been asked. That is it. This is an easy problem, and it should be simple, right? So what we'll do is we'll have a stack, or in our case in Python just an array, but we will perform the operations as such that it looks like it behaves like a stack. So we will have basically an empty stack, so let's call it this, and then we'll perform these operations. So you know that whenever we are seeing basically this x, that means we'll see an integer value which we will basically push to our stack. Then this means last two values, add them up and then push basically again to the stack. And then D means double last value, and C means basically just a pop operation, basically pop out that value, the last value. So as we go through, first time we see 5, so what we will be doing is we'll push 5 onto our stack. Then again we see 2, so we'll push 2 now to our stack. Then we see C here means pop our basically last added value. That means we'll be popping out this particular value 2, so let's remove that. So we will basically remove this. This is done. So all these operations are now done, right? These operations are now done. Then we see D means whatever the last record you have seen, the last score, then double it and push it onto the stack. So now you will double 5 and put it here. This is done. Now you see a plus means double last two values and push it to the stack. So you basically not double, basically add last two values and push it onto the stack. So now you will basically add these two up and then push it to the stack. So 10 plus 5 is 15, and this will be your final stage. So this is your final scoreboard final scores, or you can say whatever your record, whatever you have, and then you can basically return sum this stack, because that's what's asked in the problem. So I think it's a easy problem. And whenever like I'm writing, I don't know why I started writing in shitty handwriting. I'll try to improve it next time. So I think this will be the all of it. It will be of big of n time complexity and big of n space complexity because of this stack that we are maintaining. And I think that is our solution. So let's code it up. And I'm sure you already code it up. And if you're watching the series, just to, you know, like, sometimes like you want to have something going on the side, and then you keep doing your problems by yourself. You don't have to watch the whole video, just to track your problem that you have solved. So now I am going to basically what I'm going to do, write the solution. Yes, so let's have a stack, empty stack. Then we'll start our operations. So let's call op in operations, and we have been promised that all the operations that we will be doing, they will be valid. You know, all the inputs are such that all the operations become valid. That means that if we see a plus sign, that means we will definitely see two values at least on our stack, so that we can pop out those values, or not. We don't have to pop those out, but just like see those values and then double them up or add them up and push onto the top of the stack. So if my operation is let's say plus, if this is what I'm seeing, then I will basically, new value would be what I will append stack dot append last two values, sum the last two values. So last two values in stack would be, we can grab, oh my god, we can grab these values just by peeking onto the last value and then one more value, so which is this -2. Okay, this is one way of seeing, you know, what was pushed for last two times into our stack. Then I've done that. Else if case would be if you see a D, that means if OP is equals to a D, that means whatever the last value is, you've seen, peek the last value and append it to your stack. So stack dot append, what is the last value, multiplied with 2, so stack -1, which is like peeking the last value. All right, what is another case is C. So L if is if my operation is basically equals to C, that means I have to just pop the value. So stack dot pop the last value and do nothing, basically discard. Else case would be you are seeing an integer value, because those are 4 different types of values that we should be seeing in our basically operations array. So we will basically just append it to our array. So we will be seeing it as a string. So maybe I think this is the time where we might want to convert these values when we are appending to to our stack. So I'll just convert all the values to integers. So what we were pushing here, so if I get this last value, I should be getting it integer only, right? This I should be getting it as integer, and these two also I should be getting it in integer. So I shouldn't worry about, but I should worry about only pushing an integer. Okay, because if I'm pushing the integer, I should be popping out the values as integer. So this is only place where we need to actually check that conversion or cast the value. Now at the end, because it's an array, we can sum up in big of n time complexity and just return that sum. So I think that would be it. That's a simple problem, so let's not make the video too long. Okay, so if OP is oh no, it's not. I was just coding in TypeScript, JavaScript, TypeScript, same thing. I was coding in that, and it's still with me. Okay, that was a typo. Python only needs these two equal signs to basically strictly check the value. Okay, so let's submit it and then also write the time complexity. Oh, it doesn't seem very efficient, but I hope it's accepted, so I think it should be good. All right, so I'm gonna write the time complexity, which would be big of n, and space complexity would be also big of n. So I'm just seeing like why this time complexity is so little. Is it just the submission or something else? Oh, okay, that was just the submission. Otherwise I was thinking of like what enhancement you could do here, because you definitely can, like sometimes all these operations you're doing here, sometimes there are ways, okay, to improve, but usually like if your solution is accepted, that means it's for kind of following the time complexity bound that they have. So okay, so we have written that. Now let's go to AlgoYogi and mark this problem solved, and see you guys later in the next problem. Until that, bye bye.